Hello, my name is Paul Schubert. I'm fire expert from Germany, and today I like to give you a short information about escape routes, smoke protection, and how to do this in the United Arab Emirates. Here, for example, we have a nice picture from Dubai. You see high-rise buildings, you see the skyscrapers, and then you can understand that fire protection is very, very important. You have in the United Arab Emirates, you have the fire and life safety codes, and then you have, for example, in Dubai, the Dubai Building Code. Both of them are the minimum standards you need to protect the people. Very important is the self-rescue. The self-rescue means you must be sure that during a fire, during a catastrophe, during a disaster, immediately everybody can go out of the building by himself. To be sure that this is possible, you must restrict the fire spreads and you must be sure that there are a lot of evacuation routes and enough evacuation routes. Normally for this we have the structural fire protection, and today we speak about the structural fire protection. A little bit we speak about the technical fire protection to be sure that the voice alarm system, sprinkler system, emergency lamp system also work during the disaster, and must be sure that everybody can go out of the building by himself. Why we need more and more fire protection is very easy. In the new buildings we have more and more plastic, we have more and more cables, and because of this we have more and more smoke, and because of this we need more fire protection. In a building on 90/20, for example, we make this only from wood and from stone, and then if there's a fire we have a little bit water, vapor, and we have a little bit carbon monoxide and carbon dioxide, that's all. But in the new buildings now, with a lot of electronics, we have more and more smoke. The basic protection is to have smoke barriers and smoke partitions, and to limit the spread of fire and spreading and movement of smoke. In Europe we know we must decide it between smoke protection and smoke tightness. Smoke tightness, 100% protection against smoke is not possible, and it's not necessary, and it's not very good for the building. If you capsule in a building some areas completely, then you have the problem of mold. Because of this, it's okay to have a minimum of leakage. For example, in the beginning of the fire, you have a minimum of leakage, and this leakage allowed that, for example, a minimum of smoke is going from one side to another side. But we must decide where the leakage is going. If the leakage is going from one area to another, and one area is 400 square meters and another area is also 400 square meters, it is not a problem if 10 cubics of smoke is going from the door to one side to another. But if you have, for example, an escape route, you have the big problem that 10 cubics of smoke could be a lot. And because of this, in the escape routes, we must be sure that we have a minimum of smoke. And we have also the isolation. If here are some shafts and some ducts, you must be sure that if you touch the wall, that the people are not get hot. Because of this, we must capsule this. But very important is also integrity of electrical supply, because we must be sure that all the safety systems are working during the disaster. Then the emergency lamp system are working, the voice alarm system is working, and then everybody can go out of the building. Because of this, this is normally separately. Safety system and general power supply is separated. Here you see, for example, the stairs. The stairs are very, very important area, because here all the floors coming together and all the people coming together. And because of this, we need a little bit higher standards for the fire protection. To be sure that if here's, for example, in the shaft some fire, then here is a low pressure, then the hot air is expanding, and then we must be sure that the hot air, the expanded air, is not going out here from the inspection tower in the stairs. If this happens, you cannot use the stairs. Because of this, we need special doors. These special doors are normally four-sided, capsuled, and then a minimum of smoke, for example 1 cubic, maximum 2, 3 cubics, it depends on the product, are going from one side to another side. If you have a normal fire door, you have only 3-sided sealing, and then it allows more smoke from one side to another side. This is, for example, the test. Here we're making a small test. We're making a higher pressure and higher temperature inside, and we can look about the leakage, how much air is going from one side to another side, and the air is the same like smoke, how much smoke is going from inside to outside. Here you see, for example, the inspection doors. It is also in the United Arab Emirates in the standards, and then also you have a normal fire doors. Yeah, they are a little bit different. It depends on the solution and it depends on the project. Here we have, for example, the floors. The floors are on a lower level of fire protection because here, if here's a fire, for example, some electrical equipment, then the floor is full of smoke. Then you go to the stairs, and the stair must be sure that here's no smoke, that you can use the stairs during fire conditions. To be sure that this is possible, we have normally the general public supply capsuled and the emergency power supply capsuled. This is typical here. You see the photo on the left side. You see both of them are together, and then we capsule them separately, and later you see only the doors. And if here's, for example, a fire in the hospital, you can be sure that everybody can be evacuated. The power public supply is switched off, for example, but the safety systems with emergency lamps, voice alarm system and everything else is working, and you can evacuate the building, and you can be sure that all the people can go out. This is, for example, the elevator control. The elevator control is a lot of times in the stairs. Then it's very easy to capsule them to be sure that there's going no smoke from the elevator control unit if there's burning, if there's an accident or something inside to the stairs. And some systems are special. They can also work during fire conditions. Then you can use the elevators during the fire. This is how we do this. We have a big fire testing space in the University of Stuttgart. There we make the ISO curve. The ISO curve is based on the 834 standard. Then we're making a big fire inside. Outside you see nothing. Yeah, we make the measuring points and everything else outside. And here you see this is after the fire. You see nothing that there's a fire inside. And this is if you open the door, the ceiling and the gaps stop the fire. Inside is a big fire, but outside is nothing. We use this normally in a lot of hospitals. We use this in all the central banks in Europe. It is a minimum of standard to be sure that everybody can get evacuated and the escape routes are free of fire and smoke. Yeah, also we use this in the hotel, and very important, if you have batteries, then we have a little bit higher standards, and if you storage or charge your batteries in the escape routes, then we have some special boxes to be sure that there's also coming no fire and no smoke out. Batteries are a little bit more risk, but it's possible to capsule them. Yeah. If you have questions, please follow us on our YouTube, Insta and LinkedIn channel. And then if you have questions, we have a lot of local partners and some specialists in United Arab Emirates who can help you with the project and who have the possibility to make the project with you. Thank you a lot.